Okay, so looking on page 14 of your notes. So when you are at, you're going to know you have a trig equation because obviously you have a trig function in it. You're going to see an equation with a sine, cosine, tangent, etc. in it. The way you solve trig equations is you solve it like you would an algebraic equation. And you guys have been solving linear equations and you guys have been solving quadratic. Just so we're clear on some vocabulary. When I say a linear equation, what's the difference between a linear equation and a quadratic equation? Yep.
In a quadratic, the variable is squared.
Right. In a quadratic, you have the variable is raised to the second power. In a linear equation, your variable is just to the what power? To the first power. So you're just going to see an x. That's your highest exponent in the equation. So just like you did in algebra, for example, if I asked you to solve x minus 3 equals 2, how would you solve a linear equation? What would you do? What do you try and do when you're solving linear equations? You want to isolate your variable, correct? So you want to isolate the x, so you'd add 3 to both sides. That strategy does not change just because now you're dealing with an equation that has a trig function in it. All right, so for example, you want to isolate, just like I isolated the x. You want to isolate the trig function by adding, subtracting, multiplying, or dividing to both sides. Find your angle in radian mode, because when you're solving trig equations, you're again solving for angles. Some of you may want to take out a filled out unit circle. I know you've probably got about 100 in your notebooks at this point. Depending upon how well you know your unit circle, some of you may want to dig out a unit circle. All right? Now again, like I said, we are dealing with regular trig functions. So we're now opening the doors up to being in all 4 quadrants. We're no longer dealing with inverses. So we're solving the equations over the interval 0 to 2 pi. Technically, ladies and gentlemen, every trig equation will have infinite solutions. Because we talked about when we first started, we can go from 0 to 2 pi. We could go finding solutions from 0 to 4 pi, 0 to 6 pi, 0 to 100 pi. So that's why they're always going to give you a particular domain to put your solutions. And typically it's from 0 to 2 pi. All right, so let's take a look at example 1. So tangent of theta is equal to 1. So the question you're asking yourself is what angle, because you're solving for theta, has a tangent value of 1. That's what you're trying to solve for. You're solving for angles. So the question you ask yourself is what angle or angles will have a tangent value of 1. So this is where you need to think about. Now again, you're not dealing with inverses, you're dealing with regular trig functions. So tell me about 1. Is 1 a positive number or a negative number? Positive. So now you need to look at your unit circle. Where is tangent positive? 1 and 3. So I know that my solutions cannot be in quadrant 2 and they cannot be in quadrant 4. So now this is why I said some of you may need to dig out the circle. What angle in quadrant 1 has that tangent value of 1? Pi over 4. So theta is going to have to be equal to pi over 4. That's one of your solutions. But you also have to look down here in quadrant 3. So now what angle down there in quadrant 3 has a tangent value of 1? 5 pi over 4. So most of these, ladies and gentlemen, unless of course you're dealing with a quadrantal angle, an angle that's falling on an axis, you're going to have 2 solutions. So any questions on how we solve that? Let's take a look at the second one. Cosine of theta is, yeah, Austin. Since the trig function is already by itself, you don't have any algebra. Again, if there was numbers on that side, which we'll lead up to, if there were some numbers with the tangent, we'd have to get it by itself first. You always want to isolate your trig function first. So like in number 2, for example, you already have cosine all by itself. So now let's take a look. And again, the question you're asking yourself is what angle has a cosine value of negative square root 3 over 2? Well, again, get your location. Where is cosine negative? Since square root of 3 over 2 is negative, where is cosine negative? 2 and 3. So I know I'm not going to be looking for angles in quadrants 1 or 4. So always know your location and where you're looking for your angles. So now what angle in quadrant 2 has a cosine value of negative square root 3 over 2? 5 pi over 6. And what about down there in quadrant 3? 7 pi over 6. This is where I said, guys, in this unit, if you're still struggling and you don't know that unit circle, this unit is not going to be pretty for you. You've got to know it. All right, any questions on 1 or 2? So now let's take a look at number 3. So now number 3 is a little different than 1 and 2. Because is your trig function by itself on the left-hand side? No. So what are we going to have to do first in order to get the sine of theta by itself? Divide by 2. Because you want to get that trig function by itself. So we have the sine of theta is equal to negative square root 2 over 2. So now, in your unit circle, where is sine negative? What two quadrants would sine be negative? 3 and 4. So again, like I said, get your location down on where you're going to be. So what's the angle down here in quadrant 3 that has a sine value of negative square root 2 over 2? 5 pi over 4. And then the one over there in quadrant 4 would be 7 pi over 4. And again, guys, the directions are very specific. They want the angles to be between 0 and 2 pi, so you should not be giving any negative angle measurements. All right, so make sure your answers are falling in there. Again, don't confuse this with what we did with the inverses. These are not inverse trig functions. These are your regular trig functions back on the whole circle. All right, let's take a look at 4. Is the secant of theta by itself? No. So what do we have to do first to get secant by itself? Divide by negative 2. So then the secant of theta is equal to negative 2. Well, to figure out the secant of theta, then we can change it. What's the reciprocal function for secant? Cosine. So if I want to make it easier on myself, I can rewrite this as the cosine of theta. And then take the reciprocal of negative 2. What is the reciprocal of negative 2? Negative 1/2. So then wherever the secant of theta is equal to negative 2, that's where cosine of theta is equal to negative 1/2. So where is cosine negative? What two quadrants? 2 and 3. So I know my angles are not going to be in 1 or 4. So what angle in quadrant 2 has that cosine value of negative 1/2? 2 pi over 3. And then down here in quadrant 3, it would be which angle? 4 pi over 3. Okay? So any questions on that example? So let's take a look at number 5. So sometimes, just like in algebra, you have to do more than one operation to get the variable by itself. What's going to be your first step to get the cotangent by itself? What are we going to do first? Subtract the 1. Then what? Divide by square root 3. Now, since this is cotangent, don't worry about rationalizing just yet. So what you're looking at is the cotangent of theta is equal to negative 1 over square root 3. So again, what is the reciprocal function for cotangent? Tangent. And then I can take the reciprocal of negative 1 over square root 3, which would be negative square root 3 over 1, or just negative square root 3. So now what for, Ryan, not right now, sit down. Where is tangent negative? Where is tangent negative? 2 and 4. So I know I'm not looking at answers in 1 or 3. So then what's the angle in quadrant 2 that has a tangent value of negative square root 3? 2 pi over 3. And then what's the angle down here in quadrant 4? 5 pi over 3. So any questions, guys, on how we solve those trig functions when it's linear? Again, they're linear because notice all of your trig functions are raised to the first power. There is no power higher than 2, so that's why it's just a linear trig equation. All right, you guys go ahead and try number 6 for me. So again, when you go to solve, ladies and gentlemen, problem number 6, we know we have to add the 3 and then divide by 5. So we end up with cosecant of theta is equal to 1 is where sine is equal to 1. Remember, on the positive side of your y-axis, you have the ordered pair 0, 1. Remember, sine is your y-coordinate. So you're only going to have one solution for that case. So a lot of times, if you end up with the quadrantals, you're only going to have one solution. All right, you guys go ahead and try number 7 for me.